Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 10 Maths Algebra Exponents Part 2. And this is from a series of videos which deals with exponents and solving exponents. If you look at the last video, I dealt with the laws of exponents, and we need the laws of exponents to simplify these expressions. Now, these examples, or in this particular video, we're going to be dealing with simplification of exponents, where we require factorization. Now remember that in grade 10, factorization is a very important part of term 1 work. You learn how to remove a highest common factor, you learn difference of two squares, we learn about how to factorize a quadratic trinomial, and also we look at sum and difference of two cubes. Now, if you haven't already looked at the videos on factorization, go and look at factorization because that's very important. Now, the reason that we require factorization in this example is you can see that you have this plus sign over here. See, 3 to the x plus 1 plus 3 to the x, which means that we have to now remove 3 to the x as a common factor there. But before you do that, step number 1, you always want to try and write as separate terms. Now, you use the law of exponents to actually do that. Check this out. If you have, for example, x to the m plus n, it's equal to x to the m times x to the n. That comes from the law of exponents. We normally say the first law of exponents. So if you have common bases and you're multiplying, then you add the indices. So therefore, see that 3 to the x plus 1 will equals to 3 to the x, right, times 3 to the 1. Okay, so I'm going to do the same thing there now. So I'm going to say 3 to the x times 3 to the 1 plus 3 to the x there, all over 27 times 3 to the minus 1 times 3 to the x. Okay, so I'm just using this law of exponents, and there's the example there. Now, if you look at it, correction there, you can see that it's going to be 3 to the x there, right? Okay, so that's 3 to the x. Now, you can remove 3 to the x as a common factor there on the top. See there, 3 to the x and 3 to the x. You can take it out as a highest common factor. So that's exactly what we're going to do. Let's say 3 to the x into 3 to the 1 plus, what's going to be left over there? 1. Remember that you can always check your factorization by products. Like if you multiply back into the brackets now, 3 to the x times 3 will give you 3 to the x times 3. 3 to the x times plus 1 is 3 to the x. Then in the bottom here now, you're going to get 27 times 3 to the minus 1 times 3 to the x. So you can now cancel 3 to the x with 3 to the x. Cancelling means now, you see, you got 3 to the x on the top, and 3 to the x equals to 3 to the x minus x, which is 3 to the 0, which is equal to 1. So we loosely say the word cancel, but there's the maths behind cancel, all right? So what you're left with now? You're left with 3 to the 1 plus 1, which is going to give you 4. Then 27 times 3 to the minus 1. Now remember that 3 to the minus 1 is equal to 1 over 3. So this one now will be 27 over 3. Right, so we already cancelled out this. So there's nothing there now, right? So we got 27 divided by 3. So what's that? 4. 27 over 3 now will become, 27 over 3 will be 3 over 27. So remember that when you divide by a fraction, right, see, x over y divided by a over b is equals to x over y. You change division to multiplication, and a over b, you're going to swap it around. Now it becomes b over a, right? So what you're left with, 4 times, see, put that over 1. 4 times 3 is what? 12 over 27. And that's our answer, 12 over 27. Let's go look at another example. This example now came out in the DBE November 2017 paper, right? This other example here we did came out in the November 2019 paper 1. Okay, so similarly now, see, your job is to recognize that here it requires factorization because it's separated by plus or minus signs there. So factorization is what is required there. So step 1, now we write as separate terms, 3 to the t minus 3 to the t times 3 to the minus 2 all over 2 times 3 to the t minus 3 to the t. So what do you notice now? Here you can remove a common factor on the top and the bottom. See here. So you got 3 to the t, 3 to the t, 3 to the t, 3 to the t. You can remove it, right? HCF. So now you got 3 to the t into 1 minus 3 to the minus 2. And in the bottom, 3 to the t into 2 minus 1. Check your factorization by products. 3 to the t times 1 is 3 to the t. 3 to the t times minus 3 to the minus 2 will give you that there. Right? 3 to the t times 3 to the minus 2. If you say 3 to the t times 2, you'll get that 2 times 3 to the t, and 3 to the t times minus 1 is minus 3 to the t. Once you know that, you can check, then you can move on now. See, 3 to the t and 3 to the t cancel. I already explained why we say the word cancel. 3 to the t over 3 to the t is equals 3 to the t minus t, which is 3 to the 0. And remember, law for zero exponents, 3 to the 0 is 1. So what you got here now? 1 minus 3 to the minus 2. Now 3 to the minus 2 is equal to 1 over 3 squared, which is 1 over 9. Remember this law now of exponents, which says that if you got x to the minus n, it's equal to 1 over x to the n. Law for negative exponents. So we are going to apply that law. 1 minus 1 over 3 squared. Let's simplify. So what it will be? 1 over 9. Right? All over 2 minus 1 is 1. So therefore, 1 now, remember you need now a lowest common denominator to simplify. So 9 over 9. 9 over 9 is 1 minus 1 over 9. Now that you got a lowest common denominator, now you can simplify. 9 minus 1 is 8 over 9. And that's your answer. Learners, if you haven't subscribed already, make sure to subscribe to my channel, JL Maths. Also, you can check my website, which is absolutely free, and you can watch all videos in order of the work schedule. Like my Facebook page also, Justin Lazarus Mathematics, and I'll catch you in the next video.